Hello everyone, we've got quite a tricky motion time graph exam question here. So two trains, P and Q, move on horizontal parallel straight tracks. Initially, both are at rest in the station and level with each other. At time t equals 0, P starts off and moves with a constant acceleration for 10 seconds up to a speed of 25 meters per second, and then moves at a constant speed of 25 meters per second. At time t equals 20, where t is measured in seconds, a train Q starts to move in the same direction as P. Train Q accelerates in the same initial constant acceleration as P up to a speed of 40 meters per second, and then moves at a constant speed of 40 meters per second. Train Q overtakes train P at time t after both trains have reached their constant speeds. Okay, sketch on the same axes the speed time graphs of both trains. Okay, so first of all, let's deal with P. So P starts off from rest and it accelerates over a period of 10 seconds up to a speed of 25 meters per second. It then carries on with a constant speed for the remainder of the time. Q, it starts off 20 seconds after P has started, accelerates with the same acceleration, so these two lines are parallel, up until it reaches a speed of 40 meters per second, and then it continues. Okay, good. So that's our, and then basically what happens is train Q overtakes train P at some time t here. Now, there's an absolutely crucial idea which we're going to need for part C, but we'll get to that in a minute. So that's our sketch. So there's some value of time t where Q overtakes P. So that's our sketch represented. Now, part B, it says find the value of t at the instant in which both trains have the same speed. Well, I think the key for this is notice that it took train P 10 seconds to go from 0 to 25 meters per second. Now, the implication of that is it's also going to take train Q 10 seconds to reach that speed of 25 meters per second. So that is 10 seconds, okay? And that's because they've both got the same acceleration. So the time at which they're both traveling at 25 meters per second is 10 seconds after Q starts. So that's 20 add 10, so that is 30 seconds. Now, finally, here we go. Find out the value of t, and it's worth 8 marks. Oh my goodness, a lot of marks. Now, the key idea is that the areas both have to be the same, okay? Because if you imagine both P and Q, let's draw a little sort of diagram here. There is P and there is Q. P kind of like starts off moving, accelerates, and then it moves at a constant speed, okay? So it's kind of here. Q, so let's say P is here when Q is here. Then Q starts and it kind of like accelerates. But basically, at some point, there comes a moment where it overtakes Q at the time t. And notice that at the point where Q overtakes P, they've both covered the same distance away from where they started, okay? So at the moment, that's the key idea, and is the key for breaking into this question. That means that Q has traveled the same distance as P at the moment that it overtakes it. Now, how does that help us? That helps us because it means that, remember, the area underneath a speed time graph gives us the distance traveled. So it means that at the moment when Q overtakes P, they've both traveled the same distance and the area underneath the two graphs will be equal. So the area underneath, that's the key idea. Okay, so that's the bigger picture. But before we can do that, we need to, before we can calculate the areas, we need to find out how long it took Q to get up to speed. Well, let's have a look. So basically, it took 10 seconds to get to 25. Okay, so using like a direct proportion, it's going to take X seconds to get up to 40. So I've just said if it took 10 to get to 25, it's going to take X to get to 40. And then 40 over 25 simplifies into 8 over 5. And just rearrange this to make X the subject, and we find out that X is 16 seconds. So it took Q 16 seconds to accelerate from rest up to a speed of 40. So therefore it started 20 seconds later, so it had reached its speed at 36. Okay, so far so good. So now we just need to find expressions for the areas of the two trapeziums respectively. So let's deal with this trapezium, the one that relates to Q. Well, this side is t minus 20, and this side is t minus 36. The distance between them, the two of them, is 40. So that's our expression there for all the dimensions of that parallelogram. Let's have a look, not parallelogram, trapezium. Now let's look at this one. T, that is t there, so the base is t. This one is t minus 10 because it took 10 seconds to reach that speed. So that is t minus 10, and the height there is 25. Okay, so let's write down our formulas for the area of a trapezium. The formula for the area of a trapezium is we do add the two parallel sides together, halve it, and times by the distance they are apart. So for this triangle, this trapezium, it is going to be t plus t minus 10, the two parallel sides, divided by 2 times by 25. For this trapezium, it's t minus 20, add t minus 36, divided by 2 and times by the distance they are apart, okay? And those are equal because they've traveled the same distance at the point at which Q overtakes P. Now we just simply solve this, okay? So I've collected like terms in the brackets to get these two expressions just by collecting these like terms. I've then times everything by 2. I've then expanded my brackets. Then I've got all of the numbers on one side and everything to do with t on the other side, okay? Which gives us this expression here, which when we solve that is 66 1/3 seconds, which is the correct answer. So quite a key question, that one. I hope that you found that video useful, and I will see you in the next one.